So hopefully you have a nice chapter 2 section on your study sheet, right? Where you have the 4 angle pairs, you have sum of triangles 180, straight angle is 180, vertically opposite are equal. Some of you might even need a full circle is 360. I don't know. At some point it's going to show up. Okay, at some point you might use the 360 part, and you'll see when that time happens, when that comes along, you'll use it. But just make sure you understand that one. Let's finish page 33. So I asked you to have these formulas, and one thing I want to remind you is that these three ice, right? If you want to use these formulas, it has to be a regular polygon, or otherwise it doesn't work. Because these all go under the assumption that every angle measures the same inside that polygon, okay? That's why we just simply divide by the number of sides, okay? Would this work for a triangle? Yes, it would. Like, let's do, for example, the interior angle of a equilateral triangle. Sides 3, right? 3 minus 2 is 1. 1 times 180, 180. Divided by 3, because it's 3 sides, right? 180 divided by 3, 60, right? Oh, okay, equilateral, we know it's 60 all around. But this would not work for a triangle that doesn't have all angles the same, right? It would just not work. It's not always 60, we know that. So that's one example there. I talked about the notation. This n just tells us how many sides we're solving for. That's it. Let's go into, let's finish calculating them all. This is something that I would expect you to all be able to do. You figure out the number of sides, and if I ask you what's the sum of all interior angles, 540. So if I take every single angle, it's 540. And it wouldn't matter what it looks like. If it's distorted, if it's irregular, it wouldn't matter. This is always true, okay, when you do the math. Why is this important? If I were to give you 4 angles in this thing, you could easily find the 5th one. Just subtract what you know from 540, okay? That's why this is useful. The interior angle is 108. The central angle is 72. So is the exterior angle. And we notice something, that the interior and the exterior, they add up to 180. That's no surprise to us. So, by the way, the exterior angle, you could have also found the exterior angle by just going 180 minus I. Write that down, okay? Exterior angle is 180 minus 108, which is 72 degrees. So, in this case, you had a choice. Which method did you want to use? You had a choice, okay? Okay, the last one that I want to, so we did S, I, C, E, and we're missing one, right? Not very common, but you got to be, D is the number of diagonals. And the formula calls for n times n minus 3 divided by 2. Very important that you get this right, because a lot of students are like, oh, it's always divided by n. It's always divided by n. All of a sudden, it's divided by 2. So make sure you have that formula right when you copy it. So n is 5, right? So it's 5 times 5 minus 3 divided by 2. That's 5 times 2 divided by 2. Do you see something there? 2 divided by 2. You can cancel that out. But if you miss it, just go 5 times 2 is 10. Divided by 2 is 5, right? There's 5 diagonals. It's not degrees. You actually found 5 diagonals. What is that diagonal? Try to draw a pentagon. Copy this shape if you can. So I basically start with a roof like this. And then I just go slightly in a slant like this. And then close it off, okay? And I'm going to use, for the first couple, I'm going to use a red pen for the first couple of diagonals. So technically, if you go from one corner, You never travel along the sides, right? You go across the shape. So this would be 1. From this corner to this corner would be 2. That's all I can do from that corner. So we've got 2 diagonals so far. I'm going to go to this corner, and I can go across. That's 3, 4, and I'm running out of colors. But there's one more, right? Do you see it? I don't know if you do, but if I go to this corner, there's a 5th diagonal there. So there are 5 diagonals that can be drawn in this polygon. So once the number of sides goes up, the number of diagonals goes up significantly. So technically the province says you drawing them is an acceptable way of finding how many there are, but please don't do it. Because even if you're off by 1, you're wrong, right? Like if you miss 1, there's so many lines going every which way. But if you like a challenge, sure, you go for it, okay? So that's how you use these. I want to ask you to, just to warm up. No, I'm going to pause right now. Just telling you, I want you to try these formulas on page 34. So for now, we're going to say try these, right? Try it yourself, but not yet. I have one more thing that I want to show you. So you try this page when prompted to do so, okay? So put a little note at the top. You try finding all of those, use all formulas with this shape. Sometimes it's a diagram, sometimes it just tells you how many sides it has. Either way it works. Go to page 36. Working backwards. And you can't guess on these ones. Sure, you can guess to check if you did it right, but I don't want you to. Okay, I want you to actually do the math here. Sometimes you will be given one of the 5, right? So you're psyched about that, and you will be asked to determine the number of sides. Okay, so I will ask you, hey, how many sides would this tile, this shape have? We start with the appropriate formula, right? You start with the formula. Then we isolate for n. That's basically what your goal is. So for example, the sum of interior angles of a polygon is 3,060 degrees. Determine the number of sides. So they're basically saying, what is n here? So they don't give you that. So start with the formula. S is equal to n minus 2 times 180 degrees. And then we substitute the 3060, the 3060 into S. I'm going to use a different color for that, right? I substitute what I know. And now it's important to do things to save you some work, okay? Watch what I'm going to do. So our ultimate goal is to have n on its own. You can, some of you might say, oh, I'm going to distribute, Mr. Dirksen, because that's what I was taught when there's a bracket with adding and subtracting. But don't do it. It's going to make it messy. What I will do is I will divide both sides by 180 degrees first. And so we get to do this, right? Because if you multiply by 180 and divide by 180, it doesn't really matter. We can get rid of it. And on the left side, that's where the magic happens. Okay? So you just divide it and you get 17. And that's, you're left with n minus 2. You can get rid of the bracket now because nothing is multiplying it. And now what are we going to do? We're going to add 2 to both sides if you want to talk about it that way, or bring the negative 2 over to the left side adding. It doesn't matter. So if you like, if your teacher taught you, do the same thing to both sides, absolutely, that's fine. So n is equal to 19. So now you know that it has 19 sides. Okay. All right. So that's how you do the sum. This one is actually a little bit easier than the other ones. So watch this one. A regular polygon has exterior angles of 11.25 degrees. Calculate the number of sides algebraically. Exterior angle, what's the formula? We start with that. It's 360 over n. Simpler, right? There's less going on here. And so we know this. We know that this is going to substitute in there. So I'm going to go 11.25 is equal to 360 over n. What does this look like to you? We did that in the previous chapter. Does it look like a proportion to you? Got a fraction and a number on the other side. So I would say the easiest way for me to look at it is like, oh, I'm going to put a 1 under 11.25. So now I have a proportion. And remember how it went? You go to the side of the variable, start with a number, multiply, and divide. That's what you do with one of these where there's no adding or subtracting, right? Like before, the sum had like this subtracting here and something multiplying. You can't do what we're doing here. So n is equal to 360 divided by 11.25. I should say it's times 1, sure. And 360 divided by 11.25 is 32. 32 sides. And there you've solved it algebraically. And the last one. This is the hardest of them all, probably. Okay, so you ready? A regular polygon has interior angles of 171 degrees. Calculate the number of sides. What do we start with? Interior angle, right? Smile, guys. Life is good. I know I'm not helping right now. I is equal to n minus 2 times 180, and this is the one that's going to cause you some grief here. Divided by n. Okay. But there's nothing that cannot be done in math, right? We can solve just about any problem. So we substitute the interior angle here, and I will stick with the plan of showing some color there. 171, and it's n minus 2 times 180 over n. What would your gut tell you? What's the first move you should make here? I don't know. I would get rid of that n that's divided. Like whenever I see a fraction, I try to get rid of it. So whatever number, if there had been a number, I would still try to get rid of that first. Okay? So I'm going to do this to both sides. Let me use a blue color here. I will take this whole thing and multiply that by n, so I can do this. Right? And I take the whole other side and do the same thing to that side. So 171 times n, this is how you write it. Just right next to each other. We go number n, right? And then over here we're left with n minus 2 times 180. And now you might be tempted to say, Mr. Dirksen, earlier, the very first example, there was the times 180, and you divided both sides by 180, right? Did that, except for on this side we have something that's not just a number. There's an n attached to it, so that would kind of complicate things. So I will show you that I'm actually in this case distributing. So that's 171n. 180 times n is 180n. 180 times negative 2 is negative 360. And so it's 171n. I'm going to bring this, the n, over. Remember when we have n's or x's on both sides, we want to bring one of them over. Subtracting in this case, you're left with negative 360. 171 minus 180 is negative 9n. That's equal to negative 360. Divide both sides by negative 9. N is equal to 40 sides. Yikes, right? That's what you're thinking, I know. But let me introduce a much easier way of doing this. But some students just love this and they just stick with it no matter what I do. Okay? So let me give you an alternative. Or okay, so let's do it a different way. Do you remember this one? That the exterior angle is 180 minus I. Right? Remember that the exterior and the interior angles are related. So if you know the interior angle, you can find the exterior angle doing it this way. Okay, so exterior is 180 minus 171. So the exterior angle is what, 9 degrees? Hold it, what are you talking about? Let's zoom into one of the corners of this 40-sided shape. But remember, we don't know that it has 40 sides technically, not yet, right? Because I'm kind of rewinding to this point. But if you zoom into just one corner, we know that the interior angle is 171, and we know that the exterior angle at that point is 9. Okay, that's what I'm trying to tell you. I'm trying to tell you, if you are given this, think this. Think the exterior angle. Okay, so this is step number 1. Step 1 is finding the exterior angle. So now, what do we know about the exterior angle? The exterior angle is 360 divided by n. And what do we know about the exterior angle? We know it's 9, right? And now this looks like the previous example, right? In B, we did this, right? The exterior angle, we used that formula to figure out the sides in B. So I'm doing the exact same thing here. I'm putting a 1 underneath, cross multiply and divide. So it's really 360 divided by 9. No way, right? That's what you're thinking. "40 sides." So you choose how you want to do this. And so this is step 1 here, right? And then this would be step 2, in a sense, switching over to exterior angle and solving for the number of sides there. All right. I'm going to stop for a little bit. I'm going to ask you to do, if you liked, you can go 37 to 38. That's what I meant to write, sorry. 37 to 38. Plus the one I just told you about earlier, the one we said try. I prefer you go to 34, then you do 37, 38. Okay? And I'm going to give you class time, so please use it. Don't waste it. Okay? Here you go. can I just highlight a few things before we go? So just look up here. I'm going to go to 34. I'm going to ask you to go to 34. Obviously, questions B and C, I just want you to figure out all those, right? Sum of interior, central, interior, all of that, number of diagonals. So these ones should be straightforward. But what about this one here? Now you need to start thinking, what are they asking for? Okay? What am I asking for? If I ask you to solve for angle A, what angle is that? Interior. That's one interior angle, so you got to find that, use formula I, right? What about this one? Close. Remember, how many pizza slices does a central have? You see how there's like somebody tried to cheat here and get 2 slices? Okay. This is a central. So what is B? This is a central and that's a central. B is equal to 2 central angles, right? So if you found central, you're very close. You're very close. You just got to multiply that by 2. Because B, right, it has 2 central angles in it. So what if I had done this, folks? I'm gonna cheat real bad here. So I'm going to take 3 slices. Hey, I'm just going to take 1, right? How many pizza slices are there really? There are 1, 2, 3 central angles in that stretch, right? So when you're at the center, guys, watch out for, yes, it's going to involve the central angle, but you got to watch out how many central angles are we talking about. What's C here? What angle is this? That's right. So you are awake when I talk. Okay. All right. So let's go to 38, just randomly. 38. I want you to get to this part. If I asked you to solve for angle X, what would you have to do before you even start? Find the central angle. Yes. So you know that X goes from here to here, but we know that technically there are 2 central angles. There's a C here and a C there. So find the central angle. How would you find the central angle? What would you even count here? So many lines. The dashed lines are, right, added to the original. So you count 1, 2, 3, 4, 5, 6, 7, 8, 9. So I gave it away already, right? This one is a 9-sided polygon. And so you got to figure out, what else am I asking you for? I ask you for a backwards question right off the bat on 37. So please know how to do those. You can use your method, whatever method you'd like. If you need to have that on your study sheet to help you out, do that. So homework is all the way up to 38.